Press x square y square is equal to a square into y square minus x square. First point, it is symmetry. So symmetry. As this equation contains even and only one power of both x and y, and therefore this curve is symmetric about both axes. So curve is symmetric about both axes. Given curve is symmetric about both axes. The next point is origin. Origin. For checking origin, put x is equal to 0. Put x is equal to 0. Y is equal to 0. And when x is 0, y is 0, LHS is 0, RHS is 0, and therefore equation gets satisfied. Therefore curve passes through origin. So origin is present on the given curve. If origin is present, the next work is to calculate equation of tangent at origin. How we calculate equation of tangent at origin? Equate the lowest degree term to 0. So consider the given equation: x square y square is equal to a square y square minus a square x square. Degree of this term is 4, degree of this term is 2, degree of this term is 2. So there are two terms having this degree. So equate it to 0, we get a square y square minus a square x square equal to 0. This implies y square minus x square equal to 0, and therefore y is equal to plus or minus x. What it means? Y is equal to x and y is equal to minus x are two tangents at origin. But these two tangents are real and distinct, and therefore origin is called node. So origin is a node. Okay. Now the next point is points other than origin. Points other than origin. In this point, what we do, if curve is symmetric about both axes, we find points of intersection on both axes. To get point on x-axis, put y is equal to 0, and when y is 0, LHS is 0 and RHS is minus a square x square 0 implies x is equal to 0. It means for y0 we got x0, so this is nothing but origin, and already we have calculated equation of tangent at origin. To get point on y-axis, put x is equal to 0, and when x is 0, LHS is 0, RHS is a square y square is equal to 0 implies y is equal to 0. Means for x0, again we get y0, and therefore there is no point other than origin. And if there is no point other than origin, here it is not necessary to calculate equation of tangent at the points other than origin. Now the next point is asymptote. Asymptote. How we calculate asymptote? To get asymptote parallel to x-axis, equate the coefficient of highest power of x to 0. Now here highest power of x, it is at two places. So one is here, another is here. So if I collect the coefficients of x square, what I will get? Here it is x square into bracket y square plus a square is equal to a square y square. So here highest power of x is x square, its coefficient is y square plus a square. So put this coefficient equal to 0. So y square plus a square equal to 0. This implies y square is equal to minus a square implies y is equal to plus or minus a r. So there are imaginary asymptotes, and therefore asymptotes parallel to x-axis are absent. Now to get asymptote parallel to y-axis, equate the coefficient of highest power of y to 0. So which are the coefficient of highest power of y? So we will write it as x square minus a square into y square is equal to minus a square x square. So the coefficient of highest power of y is x square minus a square. Put it equal to 0, and this implies x square is equal to a square, and therefore x is equal to plus or minus a. So for the given curve, there are two asymptotes. One is x is plus a, and second is x is equal to minus a. Now we will see the region of absence. For region of absence, I will draw x-axis and y-axis. What are the steps? Plot the points of intersections. So here points of intersections are only origin, because for the given curve there is no point other than origin. Second step is, if asymptotes are present, then asymptote itself is one of the partition. So here there are two asymptotes, x is equal to a, x is equal to a, and x is equal to minus a. Okay. After considering these asymptotes, here we got four partitions. So this is 1, this is 2, this is 3, and this is 4th partition. Okay. But as curve is symmetric about y-axis, what I will do? I will check whether curve is present only in these two partitions, and accordingly, by using symmetry, I can guess whether curve is present in third and fourth partition. For that, first I will define the partition. So this x is equal to minus a, it means this point is minus a comma 0, this point is 0 0, this point is a comma 0. This partition I can define it as x less than minus a. Here minus a less than x less than 0. Here 0 less than x less than a, and x greater than a. Now what I will do, for first partition I will choose the value of x is minus 2a. When x is minus 2a, what is y square? So I will write the equation like this: y square is equal to minus a square x square divided by x square minus a square, x square minus a square. When x is minus 2a, this is negative, this is 4a square minus a square, it is 3a square, this is positive. So overall y square is negative. If y square is negative, then curve is absent in this first partition. And if curve is absent in first partition, and as curve is symmetric about y-axis, then it must be absent in fourth partition. Okay. Now for second partition, I will choose value of x is minus a by 2. When x is minus a by 2, this is positive, and here a square by 4 minus a square. A square by 4 minus a square, it is nothing but a square minus 4a square divided by 4. So this is negative, this is negative, overall y square is positive. So y square greater than 0, curve is present in second partition, and as curve is symmetric about y-axis, it must be present in third partition. Okay. Now we will trace the shape of the curve. So the next point is shape of the curve. Now by tracing the curve, first I will draw x-axis and y-axis. Okay. Now the first point symmetry we will see at the last. The second point, it is origin. Yes, for the given curve, origin is present. At origin, As origin is a node, there are two tangents. Y is equal to x, y is equal to minus x. So this line is tangent at origin, and again this line is tangent at origin. Okay. As origin is a node, there are two tangents, and these two tangents are really distinct. So y is equal to x and y is equal to minus x. Next, there is no point other than origin, so we have to drop it. Next, asymptotes. There are two asymptotes. So one is x is equal to a, and second is x is equal to minus a. So this is x is equal to a. X is equal to a. It is one asymptote, and x is equal to minus a. This is second asymptote. Now, if this line is asymptote, the probable curves are like this, because asymptote is a line which touches the curve at infinite distance. Here also probable curve like this. Again at the same time on this side, on this side. Here also on this side. Again on this side. But if we observe the region of absence, before minus a, curve is absent, and after plus a, curve is absent, and therefore I will erase these four parts. Okay. Again, as this line is tangent at origin, the probable curves are like this. Again on this side also. As this line is tangent at this point, the curve will be like this. And again on this side. But as there is no point of intersection on these two sides, because these two lines are asymptotes. These two are not the points of intersection, and therefore I will erase this part. At the same time, this part. Okay. If these 2 points are points of intersection, then I can extend these 2 points. But here these 2 lines are the asymptotes, and therefore we can extend these 2 parts. As these 2 curves lies in same partition, we have to join these curves. So I will get the curve like this. At the same time, I will get the curve like this. As curve is symmetric about x-axis, again I will get the figure like this. And here also I have to join these 2 curves. Okay. So these 2 lines are asymptotes. So here I will write this is asymptote. This line is also asymptote. Asymptote. Okay. So this is overall the nature of the curve.